Hello everybody. In our previous lecture we discuss what exactly language is. Okay, so what is language? Language is a set of all strings of terminal symbols derivable from alphabet. What is language? Language is a set of all strings of terminal symbols derivable from alphabet. Okay, so see, this term we have discussed in detail in our previous lecture. Okay, so if you have not yet gone through our previous lecture, then I request you all to please do watch our previous lecture first, okay, and then proceed with this one. Okay, now see, in this lecture I just want to discuss the next term, that is what is words. What is words? Okay, see, this words term, words are related with language, are related with language only. Okay, so for better understanding of this word we will take example of language initially. Okay, so what is language? See, it is based on alphabet. As I said earlier, if you have not yet gone through our previous session, then please do watch previous session first, okay, and then proceed with this one. Okay, now let us discuss what is word with the help of example. Okay, so before a discussion of word, here we have to first assume some alphabet. So let us assume that we are having one alphabet sigma with two symbols, let us say a comma b. Okay, then in previous session what we have discussed, what is language. So what is language? Language is a set of all possible strings. Okay, means what, how many strings we can define here on this sigma? We can define any string. Okay, like suppose a is one string that we can define on given sigma, b is another string, then ab is another string, then a b is another string. Okay, so what are they? They are string defined on given sigma. Okay, they are string. Okay, right now a a a then b then ab aab, they are called as what? They are called as string. Then what we have discussed in our last session, what is language? What is language? Language is a set of all possible string. Means when we create set of this string, then that will be treated as what? Then that will be treated as language, and language is usually denoted by using letter L. Okay, so this point we have already discussed in our previous session. Okay, now in this session we have to discuss what exactly words is. Words is, okay, now see here, after defining language, see here we define language L. Okay, this a or this b or ab or aab, they are called as words of this language. Words of this language. What I said initially, what I said before defining language L, before creating this set, what I said, only a, only b, ab, aab, they are called as string. But when we put them in set, then that will become language. And when it will become language, then after that this a, this b, this ab or aab, they are called as what? They are called as words of this language. Words of the given language L. Okay, means what I just want to convey here is, see, the term words is always associated with language, always associated with language. Whatever string that we put in state, those string become words of that particular language. Okay, I hope you are getting this particular point, or for better understanding we may take one more example. Okay, let us take one more sigma. Okay, again let us take sigma as 0 comma 1. Okay, so after defining sigma, we can define string. So as I said earlier, string is any combination of symbols from sigma. So how many symbols are there? Two symbols, 0 and 1. So 0 1, then 1 1, then 0 0 1. It can be any combination. It's not the case like you have to take only this combination. You can prepare any combination. Okay, now they are called as what? They are called as string. At this position, this 0 1 1 1 0 0 1, they are called as string. Later on, if we put it in set, then that will become what? Then that will become language. Okay, so this is a language L defined on given alphabet sigma. Okay, now what I am saying, what is word? Now after creating this set of string, whatever strings which are present in the set, they are called as words of that particular language. Means after creating a set of all this string, now this 0 is a word of this language L, or 1 is a word of this language L. Okay, or 1 1 is another word of this language L, or 0 0 1, this is another word of this particular language L. Okay, now I hope you are getting this particular point. Okay, now see, I just want to discuss one more point here, that is, see, this is important point. All words are string. Okay, but not all string are words. What I said, ought, you have to remember this point. See, as I said earlier, we have not yet started with problems. Okay, probably maybe in next 1 or 2 lecture we'll just begin with actual problems. Okay, here still we are discussing the theoretical part, and this theory is very important for understanding further problems. Okay, that's why we are we are giving, so enough time for considering for understanding these particular terms. Okay, once your basic will get clear, then you will not find any difficulty in understanding further problems. Okay, so now what a statement they have mentioned, all words are string but not all strings are word. Okay, now what is meaning of this statement? Again, with the help of example we'll discuss. Okay, see here, sigma, let us again take a comma b, a comma b. Okay, now we can define string based on this alphabet sigma. Okay, so what are the strings that we can define? A, b. You can define any string b, b, a, but it must be combination of symbols which are present in given sigma. Okay, so b, b, a, or b, a, a. Okay, and so on. Now at this point, what is a, or what is b, or what is bba, or what is baa? At this point, a comma b comma bba or baa, they are called as what? At this point they are called as string. At this point they are not a word. When this string will become word? See, when you create set, when you create set of this particular string, then that entire set, for that entire set we are giving name as language. Okay, and later on, once you prepare language, then now this will be a will be called as what? Word of this language L. Then b will be called as another word of language L, or BBA another word of language L. That's why what statement they have mentioned here, all words. Now whatever words which are there, all words will be string, but in earlier case when only strings were mentioned, we don't have authority at that point to call them as words. Okay, when string can be called as words, when those strings will be placed in the set. Okay, when you form language, then only those strings can be called as words. Otherwise we don't have an authority to call those particular strings as words. Okay, unless and until you are not creating set. Okay, now I hope your concept of word is clear. Okay, one more point I just want to discuss here is that is length of the string. Okay, this is simple point. So the length of the string s is denoted by using this see determinant symbol we have to use. Okay, and it is what? It is the number of letters present in string, so it is generally denoted by using determinant of s. So here see one example is given. A sigma is consider taking a comma b, and this is one string defined. So how many symbols are there in this string? A b a b a. So 5 symbols are there, that's why length of this particular string is 5. Okay. uh, Now see, on this sigma we may define another string as well, like b a b b a a. Okay, a. So what is the length of this particular string? It is 6. It's very simple. You have to just find how many symbols are present in respective string to find out the length of the string. Okay, so I hope this concept is clear. Okay, probably see in next lecture we'll just discuss one definition, and then from next to next lecture onwards we'll just begin with problems. Okay, so if you find any difficulty in understanding any point, then you can ask me your queries. Okay, you can ask your queries on our official WhatsApp group, otherwise you can ask your query on Google Classroom as well. Okay, so that's all for this session. Stay tuned for further updates. Thank you.